Assalamualaikum warahmatullahi wabarakatuh and have a great day. Welcome to my final year project presentation video for voltage control during islanding phenomenon. Before I start my presentation, I would like to introduce myself. My name is Nur Shahira binti Abdul Halim. I'm a 4th year student of Electrical Engineering in University Technical Malaysia, Melaka. My matrix number are B011710. My final year project are supervised by Dr. Muhammad Hendra, and my project will be evaluated by Miss Anis Niza and Dr. Aida Fazliana. Here is the content of the video presentation. First, introduction. Second, literature review. Third, methodology. Fourth, result and analysis. Lastly, conclusion. Let's begin with my presentation. First, I will present about my introduction. My introduction will be described about the research background, problem statement, scope, and objective. Research background, I will be describing what is microgrid and what is islanding, but only in general. Okay, let's start with microgrid. What is microgrid? Microgrid is a small-scale power that formed by the interconnection of low and medium voltage network of distributed generator (DG) with the energy storage such as battery, solar, and wind turbine, and more. Okay, let's move on to islanding. What is islanding? Islanding is a phenomenon where a distributed generator (DG) continues to power a site even though there is no electrical supply from the utility grid. I already explained in general what is islanding. So in this video, I will be explaining more how islanding happen in our network system. Alright, this is for example, this is our utility grid. They supply 240 volt, for example, and this is our transmission line. There's one circuit breaker, and then there's one load, and DG is connected to the load. As we know, utility and DG is supplying us power. And when it is grid connected like this, utility grid will be controlling voltage and frequency. Normally, frequency in our network system are 50 Hz. Right, what will be happen if islanding happen in network system? What is the value of voltage and frequency? In IEE 1547, they already state that DG cannot regulate voltage and frequency. So I am doing my project. I will be focusing on voltage, on controlling voltage in this part. I'll be using PI controller. From the project, I have discovered there's two problem statements. First, microgrid can be disconnected or cut off from the remain of the utility power system. Either it is non-intentional or intentional. Second, when islanding occurs, the voltage and frequency are out of safety limit as the islanded area cannot be controlled by the grid. From the previous slide, I already explained what is the problem statement of this project. As an engineer, every problem occur must have their own solution. So let's see how I solve my problem in this project. Here are the solutions of the problem. First, we need to design a controller that can maintain continuously supplying power, control voltage, and control frequency. But my project will be focusing on control voltage. Second, analysis. The controller must acquire different control depending on the state of the grid connection. Every project have their own objective. I have developed two objectives from this project. First, to evaluate and analyze the performance of voltage control of the DG when subjected to islanding and network disturbance. Second, to design and develop voltage control during islanding mode in high voltage network using PSCAD software. Two scopes in this project. First, the network used in the studies is three-phase photovoltaic PV generation connected to high voltage 33 kV with 5 mega VA transformer. Second, to analyze the impact of development voltage control on the system and power quality of the network system during islanding using PI controller. So, we are done with introduction. Now, let's move on to chapter 2, literature review. In literature review, we'll be discussing on previous study on microgrid, but only focusing on islanding mode. Alright, let's start with definition of islanding. Muhammad stated that islanding phenomenon or power island is in an electrical condition exists in a power distribution network containing distributed generation DG when a zone or an area of distribution network supplied by both power grid and DG get isolated from the grid supply due to any reason. From Alvarez journal, I have discovered there is two types of island. First, unintentional island, and second, intentional island. What is the difference between these two? First, unintentional. Unintentional is an unwanted islanding due to the fault happen in the power system, such as storm. But intentional is a wanted islanding mode operation because sometimes the utility. Alright, we are all clear about the islanding definition and type of island. Right, let's move on to microgrid system. Lim state that when the grid in grid connected operation, every DG system are generally operated to inject or supply power to the grid, which is the current control mode in stiff synchronization with the grid. These are the single line diagram of the studies. I have discovered one article that written by Sue in 2014. She stated that when the microgrid is stand-alone or interrupt from the main grid, each one DG system has to track down this islanding situation and has to be changed from current control mode to voltage control mode. So, it can supply constantly voltage to the local demand. Already know what is islanding. But how to detect islanding? Velasco state that islanding detection is based on checking the output parameter of DG units. But Mahat state that islanding detection technique can be classified into remote and local. But local can be categorized in passive, active, and hybrid. As I mentioned before, local technique can be categorized in passive, active, hybrid method. These are their techniques for each method. First, passive method. There is under or over voltage, under or over frequency, rate of change of frequency, voltage phase jump detection, and harmonic detection. Second, active method. Negative sequence current injection, impedance measurement, sleep mode frequency shift, and frequency bias. Lastly, hybrid method. There is three: positive feedback technique, voltage imbalance techniques, and lastly, voltage and reactive power shift technique. Anything that happens in distribution network must have their own advantages and disadvantages. Same goes to islanding. Ganizadi and Ibedian state that islanding operation will increase the overall security of the power supply due to the progress in the standard of supply indices. Here is the issue when unintentional islanding happen. First, the safety concern. It may expose utility worker to life critical danger of shocks and burn, who may think there is no power once the utility power is shut down, but they don't know that the DG is still operate. Second, damage to customer appliances. This may cause severe damage to electrical equipment and devices because some devices which are more sensitive to the voltage fluctuation should be equipped with such protectors. Lastly, grid protection interference. Different types of relay fuses used in grid for protection may operate during islanded mode operation. Next, move to voltage control during islanding. As far as grid voltage is concerned, the inverter voltage can be regulated in magnitude and vector. The inverter voltage is regulated by controlling the modulation index, which regulates the reactive power Q. But the phase angle of the inverter can be controlled with respect to the grid that control the active power P. Alright, let's move to chapter 3, methodology. In methodology, I will describe more about microgrid and control method in islanding. Alright, this is on the flowchart of my studies. First, we measure the voltage and the reactive power of the distribution network. If the islanding happen, we add small disturbance. After that, we install the voltage control at the system. After that, we measure the voltage and the reactive power. If the value under parameter within the allowable range, we can end the system. Alright, this is the Gantt chart of my studies for these 2 semesters. The pink color indicate for this semester, and then the blue color indicate for next semester. As I mentioned before, I am using PI controller. Here is the block diagram of the PI controller. The proportional and integral gain of the PI controller can be determined using symmetrical optimum method, SO method. The open loop transfer function that we derive from the block diagram is shown at the above of the slide. Then, to get the closed loop transfer function, we can derive from the open loop transfer function, where the KPV is the proportional gain of the PI controller, TIV is the integrating time, KC is the converter gain, TTV is the total time delay, and lastly the C is the capacitor. And then the KIV can be get from the KPV and over TIV. Alright, let's move to the condition for islanding and grid connected operation. DG not usually set to participate in regulating the frequency of the grid, neither the voltage during the grid connected mode. The external power control system are bypassed and new control system take over depend on the DG unit operators. The islanding mode need to take into consideration certain limit for frequency, voltage and harmonic. As shown in the table below, there is the certain limit for voltage since I am doing the voltage control. Mostly, people will be following from IEEE 1547 standards. So, according to them, DG's units are required to cease energizing the part of the network that they supply during certain time if the voltage falls within the range. So, the 4 chapters are result and analysis. But for this semester, I'll be focusing on how to modeling the islanding operation at the system. Then next semester, I'll be installing the voltage control at the system to control the voltage during islanding. Alright, for result analysis, I'll be showing the PSCAD simulation. This is my system network. I am using the utility grid at 33 kV, considered as high voltage, and using 3 different parameters of fixed load. 1, and then 2, and then the third one is this one here. I am using the PV inverter. This is my transformer. I'm using 5 mega VA of transformer. I'm using Y delta. I step down the voltage from 3 kV to 11 kV. Then let's run the simulation. You can see here the voltage drop is islanding mode. Okay, let's look at the value of the voltage drop. It's drop between from 19 kilovolt. It dropped until nearly 0.1, 0.2. So my system network is considered as the islanding mode because of the voltage drop right here. So the last chapter would be the conclusion. From my literature review, I can conclude that microgrid systems have become an important role in the power system because microgrid system can generate power from a conventional source and renewable source. I have achieved 50% of my objective projects. Next semester, I'll be achieving another 50%, then to achieve the objective. That's all from me. Thanks for watching.